Okay, so welcome to the last little bit for this section, section 2.2. The last couple of slides, we're just going to go over how to decide whether or not a histogram or data that you're given is approximately normally distributed. Okay, so number one, the first thing I'd like you to do is just take a minute and go to your calculator notes and learn how to graph an NPP or normal probability plot. That will help you decide whether or not the graph is approximately normally distributed or not. It's very easy. Your calculator basically does all the work for you. Once you've done that, that will help you decide whether or not the data that you're given is approximately normally distributed. Now, when you're asked the question, are the data close to normal, you want to have at least two ways to prove that it's approximately normally distributed. In this case, I'm going to show you three: how you can use a histogram, the empirical rule, and a normal probability plot to determine if this specific data regarding the usable capacity of side-by-side refrigerators, to see if that data is approximately normally distributed. Now notice it says justify your answer. You're going to have to explain. You can't just like use a histogram and say, oh, it's approximately normal. You're going to have to explain why. Same thing with the empirical rule and the normal probability plot. All right, so let's take a look first. Make sure you know how to do a histogram on your graphing calculator. Here's a histogram of your data. Notice that I have numerical scales and labels to specifically state what we're doing. Now, how do we tell from a histogram that it's approximately normally distributed? You can't just look at the histogram and say, oh, it's approximately normal. Well, how does somebody else that's reading it and looking at the graph know that it's approximately normally distributed? You want to state that it's roughly symmetric. Okay, nothing in life's ever going to be perfect, and then it's bell-shaped. So that tells us that it's approximately normally distributed because it's roughly symmetric and bell-shaped. Now, remember with the empirical rule, remember that 68% of the data is within one standard deviation of the mean. 95% of the data is within 2 standard deviations of the mean, and 99.7 is within 3 standard deviations of the mean. So in order to find to see if this data follows those percentages, number one, find your mean. Okay, after you find that mean, notice we're using the sample standard deviation because this is a sample. Then what you want to do is find the intervals that define 1 standard deviation away from the mean, 2, and then 3. So X is in the middle, so you'd add 1 standard deviation, subtract 1 standard deviation. There's your first one. That should be about 68% of the data. The second interval, you're going to add 2 standard deviations, subtract 2. Your third interval, add 2, subtract 2, or you could draw a curve if that's easier, just to see where the labels are. Then you physically want to count how many data points are within this first interval. So in this case, 24 of the 36 were. Figure out what that percentage is. Or the second one, how many data points are in that interval? 34 out of 36. Okay, 94%. And for the last portion, 36 out of 36 or 100%. So then you don't just want to give this, you want to give some sort of explanation. Like, does this fall in the empirical rule? Why? Does it not? Why not? So look at what this explanation says. The percents are quite close to what we would expect based on the 68, 95, 99.7 rule. Combined with the graph, this gives us pretty good evidence that it's close to normal. So you're always making sure that you do 2 proofs to show that it's approximately normally distributed. Obviously, this is off by about 3. This is off by 1. This is off by just a smidge, but these can be off by a couple percentage points, and that's okay. There's no like hard and fast rule for if they're off by 5, it doesn't work. Okay, and then the last one is using a normal probability plot. Honestly, this is probably the easiest because you can do this on your graphing calculator. So below is the normal probability plot. Remember, sometimes you'll hear it called the normal quantile plot of the refrigerator data from the previous page. It's pretty linear, supporting our earlier decision that the distribution is close to normal. So you have to draw the plot. Make sure you label your axis, and then please make sure that you state it's linear, therefore it's approximately normally distributed. Don't just draw the plot and say, oh, it's approximately normally distributed. How did you know from looking at it that it was? You knew because it was linear. All right, so in this section, this is just what we took a look at. We took a look at specifically the normal distributions are described by a special family of bell curves, so the normal curve. Make sure you understand this notation. When you see the n, mean and standard deviation, that tells us it's approximately normally distributed. That sort of defines what our graph looks like. Remember, the mean is the center of the curve and the standard deviation is the distance from the mean to the change of curvature points on either side, okay, one standard deviation away specifically to where it changes from concave up to concave down. Most all normal distributions follow the empirical rule, and basically that just tells us what percent of observations should lie within 1, 2, and 3 standard deviations of the mean. Remember, all normal distributions are the same when they're standardized. The standard normal distribution has a mean of 0 and standard deviation of 1. That's basically your z-score distribution. Know how to use the table A and your graphing calculator to find percentile rank, the percent of the area under the curve, etc. And then in order to assess normality, you want to choose at least 2 of 3 methods in order to tell whether it's normal. You can use a normal probability plot from your graphing calculator, 68, 95, 99.7 rule, or a histogram.